So the optical genome mapping, it's a non-sequencing based approach to evaluate structure variants in any malignancy. And I have experience using the myelodysplastic syndrome cases. Our group has characterized more than 100 MDS cases using combined optical genome mapping with targeted next generation sequencing. So we have shown in our recent publication that using this combined methodology can not only improve the risk stratification using the IPSS-R, but it can actually uncover certain novel cryptic aberrations that are not only prognostic but also targetable using clinical trials. So we are also aware that now we have the two new classification systems, the WHO 2022 and the ICC, and we have the new prognostication, the IPSS-M. Now if we look at the diagnostic classification systems, both the WHO and the ICC, they have both taken a genomic-based approach to diagnosis. That actually means that it actually requires a pretty robust genomic characterization of the malignancies in order to have an accurate diagnosis and to use the IPSS-M model. And we've shown that using what we propose, the OGM, the optical genome mapping, with NGS can actually enable accurate characterization. And we performed that analysis in our database, and we were able to conveniently reclassify all the cases using the updated WHO. Next, for the IPSS-M, one limitation that most labs face is to characterize the biallelic nature of the TP53 mutation, which is understandable unless you do probably a simultaneous FISH or a chromosomal microarray to evaluate the deletion and the copy neutral LOH, or maybe a sophisticated NGS algorithm to extract that information. It might limit the use of IPSS-M model. And this aspect is actually overcome by the use of optical genome mapping, which can provide all of that data in just a single assay. And the IPSS-M, the second aberration would be the KMT2A partial tandem duplication, which requires another PCR assay setup, or in some cases we can extract that information again from microarray, which again to the lab means just doing multiple FISH, microarray, and the NGS testing. So there's a lot of burden on the lab side that can easily be overcome again using optical genome mapping, because we are easily able to identify these partial tandem duplications. And I think moving forward, there needs to be multiple studies to validate our approach, and hopefully data can be collated and to evaluate the efficacy.